Hence option A is correct. Is closed loop transfer function of the unity feedback system is shown below. Find its type and order. Here the type means the number of poles at the origin in case of an open loop transfer function. Means for we have to decide the type and order from the open loop transfer function. Okay, order is number of poles, type is number of poles at the origin. Here first of all, this is the closed loop transfer function. We have to derive open loop transfer function. Closed loop transfer function is nothing but g of s by 1 plus g of s in case of unity feedback system. Okay, which is s by 2s plus 1. From this we have to get open loop transfer function, that is g of s is nothing but s by s plus 1. So if we simplify this particular equation, we will get this. So the number of poles at the origin is 0. That's why it is a type 0 system. Now the number of poles, non-zero poles are, the number of poles are here 1 itself. Hence type 0 and order 1 system, that is option C is correct. The question is, the dynamic response of a system is very weak, then the controller required to make the reliable system is. So here, if we want to improve the speed of the system, that means we have to decrease the rise time of a system. That is done by proportional derivative controller. Here in the question itself is mentioned here is that only we have to improve the dynamic response. There is no concern about the stability of the system. Hence we have to use proportional derivative controller. Option B is correct. Yes. An FM signal with a frequency deviation of 10 kHz at a modulation frequency of 5 kHz is applied to two frequency multipliers connected in cascade. That means, and the first multiplier doubles the frequency and the second multiplier triples the frequency. The modulation index of the FM signal obtained at the second multiplier output is. Here, this is the FM signal. According to the question, it is having delta F, that is 10 kHz, FM is 5 kHz. So it is passed through a cascade connection of two multipliers, that is first one is doubles the frequency and second one is triples the frequency. So here what happens is, when we are passing a FM signal through a multiplier, only deviation gets affected. The modulation frequency is not going to be affected. 2 delta F, this is FM as it is. Here is 6 delta F, FM is as it is. We have to calculate the modulation index at the output of the second multiplier. We know that in case of an FM, that is frequency modulation, modulation index beta equals to frequency deviation divided by modulation frequency. Here the frequency deviation is 6 del F, it means 6 into 10 kHz and 5 kHz, that is nothing but 12. Hence option A is correct. A DSB-SC modulated signal is transmitted over a noisy channel with PSD shown below. The message bandwidth is 4 kHz and the carrier frequency is 200 kHz. The average power of the modulated wave is 10 watts. After the coherent detection, output SNR is. Here the DSB-SC spectrum is given as double sideband suppressed carrier. Here this is bandwidth is 8 kHz, because the bandwidth in case of DSB-SC is nothing but 2 FM. FM is the bandwidth of the message signal, that is 4 kHz, it is 8 kHz. It is distributed around center frequency, that is 200 kHz. Here also in similar way, that is this is minus 200 kHz and the bandwidth is 8 kHz. So if we are passing this signal through a channel which is having a PSD in this way, means the signal is going to be affected in this way. Here this is the PSD of the channel. This is 400, means exactly middle we will get 200 kHz. The signal bandwidth is 8 kHz. Here also this one, this is minus 400 kHz. So exactly middle way we will get minus 200 kHz. The magnitude is 10 power minus 6 watts per hertz. So here it is a linear variation over the top of this portion. So we can approximate it to the average value, that is in this way. So this magnitude is at 200 kHz we have to calculate. This is a linear portion. So if we calculate, we will get here is 0.5 into 10 power minus 6 watts per hertz. Okay. Hence, here first of all DSB-AC signal X of t is AC M of t cos omega ct. So after passing the X of t through the channel, we will get X of t plus N of t. Whereas N of t, it consists of two components. One is the in-phase component and the quadrature component. So this is detected through a coherent detection. That means the quadrature component is get eliminated. So the resulting signal y of t, if we assume AC M of t plus Ni of t is the output of the receiver. Okay, the power of this is the signal component, this is the noise component. Here the signal power already it is given in the problem, that is because this is the modulated wave. Okay, signal this power is AC square P by 2, which is 10 watts. The noise power is given as noise power equals to twice into 0.5 into 10 power minus 6 into 8 kHz this. So it is around 8 millivolts. So signal component by noise component, that is SNR at the output of the DSP-AC receiver is 10 by 0.008. So if we apply the logarithm, that is in dB, we will get it as 31 dB. That is option A is correct.
Generator, okay, if you have maximum current, then power factor will be lagging, leading, unity, or either A or B. In synchronous generator, if you see the curves here like this, it will be there. Okay, this is the maximum value of current, and this is also maximum value of current, and this zone is UPF zone. Okay, less than UPF zone you have leading power factor, whereas over excited zone we have lagging power factor. So this point comes under leading power factor zone, this point comes under lagging power factor zone. So maximum current is possible both in leading and lagging zone. So either A or B is correct answer. So option D is right.